Welcome to today's episode of Tech Talk, the Future of AI, where we dive deep into the world of AI and data science. I'm your host, and today we're exploring a fascinating topic, large memory models, or LM2. Joining me are some of the brightest minds in the field. Let's get started.
Thanks for having me. So, LM2 is like that friend who remembers everything, even the little details you forgot about your last conversation. It's designed to enhance traditional transformer models by adding a memory module that helps with long-term dependencies.
Right, and this memory module is a game changer. It acts like a librarian, storing and retrieving information efficiently. This is crucial for tasks that require reasoning over long contexts, like the needle in a haystack problem.
Yeah, it's like trying to find Waldo in a crowd of Waldos. But seriously, LM2's ability to outperform other models like RMT and Llama 3.2 is impressive. It's like upgrading from a bicycle to a sports car in terms of processing power.
Absolutely. The LM2 model incorporates a memory bank that interacts with input tokens via cross-attention. This allows it to maintain the original information flow while integrating additional memory pathways. It's like having a GPS that not only shows the route, but also remembers all the shortcuts.
And let's not forget the business implications. For AI engineers and data scientists, LM2 offers a scalable solution for complex reasoning tasks. Imagine applying this to customer service chatbots that can remember past interactions to provide more personalized responses.
That's an excellent point. But how does LM2 ensure that it doesn't degrade performance on general tasks?
Well, that's where the gating mechanisms come in. They control how much information is stored and retrieved, much like a dam regulating water flow. This ensures that the model remains efficient and doesn't get bogged down by irrelevant data.
I agree, but I have a slightly different perspective. The real magic lies in the balance between memory and attention. The model uses learnable control gates to decide what to remember and what to forget, just like how we selectively remember important meetings and forget the mundane ones.
Or like how I conveniently forget my chores. But jokes aside, this selective memory is crucial for maintaining performance across various tasks.
And the experimental results speak for themselves. On the Babylong benchmark, LM2 outperformed the RMT model by 37.1% and the Llama 3.2 model by 86.3%. It's like having a chess grandmaster who not only knows the rules, but also remembers every game they've ever played.
Exactly. And this has real-world applications. For instance, in finance, LM2 could analyze long-term market trends and make predictions with greater accuracy. It's like having a financial advisor who never forgets a stock's history.
That's fascinating, but are there any challenges or limitations we should be aware of?
Well, one challenge is ensuring that the memory module doesn't become a bottleneck. It's like having a supercomputer but only using dial-up internet. The integration needs to be seamless to maintain efficiency.
And there's also the question of interpretability. While LM2 excels at reasoning, understanding why it makes certain decisions can be as complex as deciphering a Shakespearean play.
In a playful tone, to be or not to be, understandable, that is the question. But seriously, improving interpretability is an ongoing challenge in AI research.
Indeed, but the potential benefits far outweigh these challenges. The ability to handle long context problems opens up new possibilities in fields like healthcare, where models can analyze patient history over time to make better diagnoses.
And let's not forget education. Imagine an AI tutor that can track a student's progress over years, providing personalized learning paths. It's like having a teacher who knows you better than you know yourself.
Wow, the possibilities are endless. Before we wrap up, any final thoughts or surprises you'd like to share?
Just that LM2 is a testament to how far we've come in AI. It's not just about making models bigger, but making them smarter, more efficient, and more human-like in their reasoning.
And I'd add that collaboration between business leaders and AI experts is key to unlocking its full potential. After all, as the saying goes, alone we can do so little. Together we can do so much.
Here. And remember, folks, the future is not something we enter. The future is something we create.
Well said. Thank you all for joining me today. This has been an enlightening discussion on the future of AI with large memory models. Until next time, keep innovating and stay curious. Welcome back to part 2 of our deep dive into large memory models, or LM2. In our previous episode, we explored the conceptual framework and potential applications of LM2. Today, we'll delve into the technical intricacies and business applications. Let's jump right in.
Great to be back. Let's start with the architecture. The LM2 model is built on a decoder-only transformer framework, enhanced with a memory module. This module acts like a dynamic filing cabinet, storing and retrieving information as needed.
Exactly. The memory module is integrated into each decoder block, interacting with input embeddings through cross-attention. It's like having a librarian who not only organizes books, but also recommends the best ones based on your current needs.
And don't forget the gating mechanisms. These are crucial for controlling the flow of information. Think of them as the security guards of the memory bank, deciding what gets in and what stays out.
Right, and this is where the magic happens. The input, forget, and output gates work together to ensure that the model retains relevant information while discarding what's unnecessary. It's a bit like Marie Kondo for data, keeping only what sparks joy, or in this case, relevance.
From a business perspective, this architecture is a game changer. It allows for more efficient data processing, which is crucial for industries like finance and healthcare, where long-term data analysis is key.
Speaking of business applications, how can LM2 be implemented in real-world scenarios?
Well, one exciting application is in customer service. Imagine a chatbot that not only answers questions but also remembers past interactions to provide a more personalized experience. It's like having a customer service representative who knows your history and preferences.
In the realm of healthcare, LM2 can be used to analyze patient records over time, identifying patterns and making predictions. It's like having a doctor who has read every medical journal and remembers every patient case.
And let's not forget education. An AI tutor, powered by LM2, could track a student's progress over years, adapting lessons to their learning style. It's like having a personal tutor who's always up to date on your academic journey.
In finance, LM2 can analyze market trends, making predictions with greater accuracy. It's like having a financial advisor who never forgets a stock's history and can foresee future market shifts.
And in manufacturing, LM2 can optimize supply chain management by analyzing historical data and predicting future demand. It's like having a logistics expert who knows every detail of your supply chain.
These applications sound promising, but what are the challenges in implementing LM2?
One challenge is the computational cost. The memory module adds complexity, requiring more resources. It's like upgrading from a compact car to a luxury SUV. More features, but also higher maintenance.
And there's the issue of data privacy. With models storing more information, ensuring data security becomes paramount. It's like having a vault. You need to ensure it's impenetrable.
And let's not forget the interpretability challenge. Understanding why LM2 makes certain decisions can be as complex as deciphering a mystery novel.
But despite these challenges, the potential benefits are immense. The ability to handle long context problems opens up new possibilities in various fields.
Absolutely. The key is collaboration between AI engineers, data scientists, and business leaders to ensure that LM2 is implemented effectively and ethically.
Well, that's a wrap for part 2 of our exploration into large memory models. Thank you all for sharing your insights. This has been a fascinating discussion on the technical and business aspects of LM2. Until next time, keep pushing the boundaries of what's possible with AI.